In this video, we're going to do example number 4. We have a block sitting on a table at rest. Another block is placed on top of the first block, and we want to find the normal force. So we're going to do number 4. Okay, so the first thing I want to do is I want to draw a picture. So I'm going to have my block M, and I'm going to put the block M2 on top just so I can see what's going on in this. Okay, so what I'm going to do is I'm going to go ahead and draw my motion diagram. My velocity is 0, and my acceleration is 0. There we go. Now it looks more purple. Okay, so now what we're going to do is we're going to draw our free body diagram. Now, when we draw the free body diagram, we're going to answer the two questions, what's physically touching and what's acting at a distance. So what's physically touching the block? M2 and also the table. So what's acting at a distance? Earth. Okay, so we know that we have three things touching. Are we in equilibrium? Yes, we are. Okay, so we're going to draw those three forces so that when we add them up, they're going to give us 0. So I'm going to start out with my dot, which is my my object. Okay, I'm going to go ahead and draw the force on block by Earth here. And then I'm going to draw another one, and that's going to be the force on block by the other block. Okay, now what I have to do is I have to actually measure these lengths. So I get, let's see, right there is 1, and here I get 1.5, and so I'm going to make this 2.5 long going up. Okay, and there are my three forces. So we have force on block by block 2, vector sign. We have force on block by Earth, and we have force on block by table. Okay, so now we're going to go ahead and apply Newton's second law. The sum of the forces is equal to ma. Because we're working in the y direction, I'm going to put a subscript y. Now we're going to go ahead and add up all the forces acting on the block. So we have force on block by table plus the force on block by the Earth plus the force on the block by block 2. And that's all equal to ma sub y. Okay, am I accelerating? No, I'm not. So this term goes to 0, Newton's first law. Okay, so now what I'm going to do is I'm going to substitute in magnitude and direction. So I have force on block by table, j hat, minus capital M G j hat, minus capital M2 G j hat, and that's equal to 0 j hat. Okay, I'm going to divide both sides by j hat. And now I have force on block by table minus mg minus m2g is equal to 0. I'm going to add these two terms to the other side, and I have force on block by table is equal to m plus m2 times g. All I did was I factored out a g and then took both of these terms over to the other side. Now this is the magnitude, and I need the direction. Okay, so I'm going to have F on block by table is equal to m plus m2 g j hat. Notice I'm not putting a negative here. I'm not putting a negative because this force is going up. Okay, you go by the direction of the force. If you look at your free body diagram, force on block by table goes up. That means that we have force on block by table going in the j hat direction. Okay, box your answer. And there you go. That's the solution for number 4.